Welcome back, class. Now we move to the next segment, which is one-to-one mapping. Let F maps X into Y be a mapping. The relation F is called a one-one mapping if different elements in the domain X have different images in the codomain Y. That is, F maps X into Y is a one-one mapping if F of X1 is equal to F of X2. That is, X1 is equal to S2, or F of X1 is not equal to F of X2, implies X1 is not equal to X2. Example, F maps X into Y. Under X we have A, B, C, D, E. Under Y we have the elements F, G, H, J, K. Every element in X has a unique element in Y. Number 2, onto mapping. Let F maps X into Y be a mapping. The relation F is called onto if every element of the codomain is an image of at least one element in the domain. Example, let H maps P into Q be defined by the figure H maps into Q. H maps P into Q. Under P we have A, B, C, D. Under Q we have E, K, D, H. In the mapping above, F of A is equal to K, F of B is equal to K. F of C is equal to G, F of D is equal to H. Elements A and B have the same image F, hence the name onto. 3. Special mapping. Let F maps X into X be defined by F of X is equal to X for all X containing X. Then F is called an identity mapping. This is a mapping that takes an element into itself. Example, let G maps X into X be a mapping as shown below. G maps X into X. Under the first X we have J, K, L. Under the second X we have K, J, L. J is mapped into J, K is mapped into K. So that is identity mapping. Constant mapping. Number 4, constant mapping. Let F put X into Y be a mapping which assigns every element in X, the domain, the same image in Y, the codomain. Example, F maps X into Y. Under X we have the elements A, B, C. Under Y we have the elements D, E, F, where A is mapped into D, B mapped into D, C also mapped into D. The fifth one, number 5, composite mapping. Let F maps X into Z and G, Z is mapped into Y. Be two mappings such that the codomain of F is the domain of G. Example, F and G maps X into Z, Z into Y. That is, F maps X into Z, and G maps Z into Y. Now, under X we have elements A, B, C, D. Under Z we have E, F, G, H, and under Y we have elements J, K, I. From the mappings above, F of A is equal to G of E, which is equal to J. F of B is equal to G of G, which is equal to J. F of C is equal to G of N, which is equal to K. And F of D is equal to G of F, which is equal to I. So bye for now, class. See you after the time.